Okay, we're going to look at this integral here, and we're going to have to use integration by parts. I have an exponential and a trigonometric function. Both of these are cyclic, they won't bottom out, so we're going to be looking for ourselves to return back to the original function at some point. So I'm going to make some things easier here. I'm going to do a substitution. I'm not going to call it u because we use u and v in integration by parts. So I guess for clarity's sake, I guess I'll make it nu will equal 7 theta, and then in d nu will equal 7 d theta. That means I can come over here and I can replace the 7 d theta with d nu, and so I have e to the nu sine nu d nu. And I'm going to use my integration by parts. I'm going to have u equal e to the nu, and so du is going to be e, well, I'll just say u prime is e to the nu d nu. So that means v prime will be sine of nu, which came from a v of negative cosine nu. So I'll put this into my integration by parts formula. U times v minus v du, which means that we have e to the nu cosine nu with a negative sign in front of it minus a negative cosine, so plus e to the nu cosine nu d nu. Right? There's our du part, e nu du, e nu du. There's our v part, negative cosine, so the negative comes out making that positive. We get negative e nu cosine nu plus e to the nu cosine nu d nu. We will now do integration on parts here. So I'm going to make my nu u, I'll use changing of colors here, e nu. So u prime or du is e to the nu d nu. That means v prime in this case is cosine u, and that came from sine u. So now I can rewrite this here as negative e nu cosine u, because that stays the same, plus, now this is going to have a uv, so that's going to be e nu sine nu, minus the integral of v du, or e nu sine nu d nu. And I know that I've ended with the same thing I've started with. So if I put this all together, if all these pieces come back together for us here, I started with e nu sine nu d nu, and we set that equal, and we expanded it out, and we get this expansion here. I'm going to do a little bit of rearranging. I'm going to put my positive terms first. I'm going to factor out this e nu, and then I'm going to have a positive sine nu minus cosine nu. Right, that's those two factors that are there. And then in minus the integral of e nu sine nu d nu. And now I'm going to add one of these to each side. So if I add e nu sine nu d nu integral, I'm going to end up with two of them over here. E nu sine nu d nu equals e nu sine nu minus cosine nu. And I'll divide by 2. So my integral sine e to the nu sine nu d nu is equal to e to the nu over 2 times sine nu cosine nu. But nu was 7 theta, so this becomes e to the 7 theta divided by 2 times sine of 7 theta plus c. Cosine nu plus c. And so there we have the answer to our integral. Oops. That should be a theta, not a nu.